All right, welcome to the Explainer. Today, we're going to talk about something you use every single second you're online, but you probably never even think about it. We're going to demystify the powerful, invisible engine that runs our entire digital world.
Okay, so let's just dive right in. Have you ever stopped to wonder, where do the billions, and I mean billions, of videos on YouTube actually go? Or every single product listed on Amazon?
Or think about all the online stores you use, like Daraz. Every single user account, with all those names, addresses, and order histories, has to be stored somewhere safe and organized.
And it's the same for every single song on Spotify. Every artist, every album, every playlist you've ever made. Where does all of this stuff actually live?
Well, the answer to all of this is something called a database. It is, without a doubt, the true unsung hero of the digital age. It's this powerful, highly organized engine that's just constantly working behind the scenes. Now, here's a really simple but kind of brilliant way to think about it. A database isn't just some messy digital closet where you throw information. No, it's more like an army base, a super structured, central place designed to efficiently store, manage, and access everything inside. Only instead of soldiers, it's data. To really get why this is such a game changer, let's take a quick trip back in time. I mean, before we had these sophisticated digital systems, how on earth did people manage huge amounts of information? Picture this. A local shopkeeper carefully writing down every single sale and credit in a giant, heavy ledger book. Or think about your school, trying to manage thousands of student records, grades, and attendance sheets in these massive, clunky filing cabinets. It was all done by hand. And this chart just lays it all out, right? The difference is night and day. The old paper method was painfully slow, full of human errors, and trying to find one specific thing, like, say, one student's math grade from 3 years ago, could literally take hours. A database makes those tasks instant, accurate, and unbelievably easy. So how do they pull this off? What's the secret sauce that makes them so much more efficient than just, dumping everything into one big file? Let's stick with that school records example. The early, kind of clumsy digital approach would have been to create one massive spreadsheet to hold every single piece of information about every student. And you can see the problem right away, can't you? In a table like this, the student's name and their father's name get repeated for every single exam they take. As you add more students, more exams, this file just gets gigantic, slow, and it's full of duplicated or what we call redundant data. It's a mess. But there is a much, much smarter way. And this is the big idea, really. It's called a relational model. And the core concept is to break information into smaller, logical pieces and then connect them. This idea is what unlocked the speed and scale of the entire modern internet. So first, you create a really simple, clean table that has only the core student information, nothing else, just who they are. Then, you make completely separate tables for other stuff, like their exam marks. See? This way, the student's name isn't repeated over and over. But hold on, this brings up a new question. If the information is in different places, how does the system know which marks belong to which student? And this is where the real genius of the system comes into play. The tables are linked together using a special kind of identifier called a key. A primary key is a field where every single entry is guaranteed to be unique. Think of it like your national ID number. It only refers to you, nobody else. In a database, this key ensures that the system can find one specific row, one student, one product, one order, with zero ambiguity. So back to our school example, the roll number is the perfect primary key. It acts like a bridge. It allows the database to see roll number 1 in the marks table and instantly know that connects to Abel in the student info table. That's how these relationships are built. Okay, but what if no single column is unique? For instance, in a huge school, there could be a roll number 5 in class 6 and another roll number 5 in class 7. Well, in that case, you can just combine two columns, like class and roll number, to create what's called a composite key. Together, they become the unique identifier for every student. All right, so we've seen the how, but what about the why? Why go through all this trouble of separating and connecting data? What's the real-world payoff for this super organized system?
All the benefits are massive. You get rid of all that duplicated data, which means your information is way more accurate. You get much better security and super easy backups. But the real game changer, the reason your favorite apps feel instantaneous, is the incredible search speed.
This efficiency is what lets a company manage 1 billion users just as easily as it manages 1,000.
And that brings us to a final thought. When you really stop and think about it, from global banking and social media to your own saved games, it's not just that these things use databases, it's that they simply couldn't exist without them. This invisible, orderly structure isn't just supporting our digital world, it is the foundation.